Hello, welcome to this video where we look at matrices and matrix operations. This should hopefully be a review of what you covered in year 10 and year 11. So this should be pretty quick. Couple main things we need to get out of the way is that for year 11 and year 12 course, what we need to know going towards the end of year exam is that we only deal with two different size matrices. We deal with 2x2s and 2x1s, which there's two examples of there. And you're only required to add, subtract, multiply, and for multiply there's two different types, scalar and matrix multiplication, and then also find the inverse of matrix, which we will do later on in the course. Some prerequisite knowledge that we'll cover really quickly. That should hopefully be a review. If it's not a review and this is completely new to you, have a look in your textbook for more in-depth detail. Matrices, we give a capital letter to the name. So when we talk about find matrix A or find matrix B, we will be looking for finding a capital letter. So we have this example here, there's a matrix down below, and we're going to call that A. And that'll come into when we talk about element in a second. Now the order or size, which we referred to briefly up here for these two matrices, order is the size of matrix. It lists how many rows it have and how many columns it has, and it lists rows first, then columns. The way I like to think of how to count to deal with matrices is we always start in the top left corner and then we drop and then slide across. Okay? So I always find that if you come up with your own way to remember the order, it's a little bit annoying because that's the opposite of Cartesian coordinates, because we're effectively counting down first and then going across, but I like to think of drop and slide, and that holds us in good stead for everything else. So if we count down, we can quite clearly see that there's 1, 2, 3 rows as we go down, and then as we count across, we can see there's 1, 2, 3, 4 columns. So we would call this a 3x4 matrix, just like up here. This went down 2 and across 2, so that's a 2x2, and this one went down 2. We went down 2 and then across only 1, so that's called a 2x1 matrix. So that's the order. Now within the matrix we have the individual data components. Matrices are used very in the real world, or their common use is as a holder of data, coefficients, something. So we need to be able to refer to those individual bits of data, and that's called an element, which is an individual entry within the matrix. The notation for the element is the lowercase of the same letter as the name. So in this case, we call this matrix capital A. That means all elements within that will use the lowercase a. If we call this matrix B, then we'd have to use lowercase b for the elements within it. And then we put the element's location by same thing, stating how far down it is, how far dropped, and how far across it is as a subscript. We want to make sure we don't write A31. That's incorrect. We want to write A subscript. Okay, and generally I like to put a comma in there just to really make it clear that that's not A31, because in computer systems and that, you could be dealing with matrices that are hundreds and hundreds of rows long. We're not going to in this course at the moment, thankfully, but still a good habit to be in, to put the comma in between just to be clear for the notation. So if we wanted to look at student 3 and their third test result, we are going to, their second test result, which is here, we would refer to that as A3. That's a typo there. That should be a 2. A32. Okay, because we go down 3 and then across 2. And we can see the score is 70. So that's our prerequisite knowledge. Matrices are given a capital letter. We count rows going down, then columns going across. Elements are an individual component within matrices, and we use a lowercase letter. Right, we can only add and subtract. We're going to look at the operators. We're going to look at adding, subtracting, and scalar and matrix multiplication. You can only add and subtract matrices of the same order. So in this case, we couldn't add. This is a 2 by 2, and this is a 2 by 1. We can't add that together. We can only add matrices of the same order. So let's have a look at how we do it. It's just adding the individual elements in each spot, and we end up with a matrix of the same size. So let's look at A plus C. So A is a 2 by 2, C is a 2 by 2, so we can add those together. So just to write the full notation out so you can see it quickly. Negative, I need to put a plus sign in between, 2, -3, 7. All we're going to do is add the matching elements. So I'm going to add the 2 and the -3. I'm then going to add the 4 and the -3 and keep that pattern going over and over and over. So just to show full working out in this first one, we get 2 plus -3 in the top left. We get 4 plus -3 in the top right. We get -1 plus 2 in the bottom left, and then we get 3 plus 7 in the bottom right, which will equal -1, 1, 1, and 10. That's how we do that. B minus D, well, we're now going on to example B. B minus D, we have a 2 by 1, and D is a 2 by 1, so we can do that. We're allowed to do that. So we get -5, 2, subtract 1, 4. In this case, D has no negatives in it, but you want to be really careful, making sure you watch your signs. But we quite simply get -5 take away 1 is -6, 2 take away 4 is -2. There's our answer. A take away C. Again, A was a 2 by 2, C is a 2 by 2, so we're allowed to do that. So 2, -1, 4, 3, take away -3, 2, 7. Same thing here, we're doing a subtraction. We've got to be really careful with signs. We get 2 take away -3, so that's adding 3, so we get 5, 4 take away -3, that will be 7. -1 take away 2 is -3, 3 take away 7 will be -4, and we're done. So that's adding and subtracting. So we just add the matching elements and get a matrix result that's the same size. Rightio. Now there's there's two main types of matrix multiplication in notation. We have scalar, okay, multiplication, and then we just have pure matrix multiplication, or sometimes referred to also as vector multiplication. Scalar means where we have some full matrix. In this case, we might call this C, and we're multiplying by a scalar number. So a scalar just means a single number. It could be an integer, it could be a decimal, it could be, it's pretty much any rational number. And all it is multiplying this number here by each element in the matrix. So 3 by 1 gives me 3. 3 by 2 gives me 6. 3 by 5 gives me 15. 3 by -3 gives me -9. So that's scalar, that's the easiest one. Now the next two the next two are both vector multiplications, which is when we multiply a 2 by 2 by a 2 by 1. And then on the next slide, we're also going to look at a 2 by 2 by a 2 by 2, which is our hardest one that we're going to have to do by hand. When we have vector multiplication, so we're not multiplying by a single number at the front, we're multiplying any two matrices together, what happens is we multiply the row by the column to get the final element position. And we can only do matrix multiplications if the amount of rows, so the amount of, let me get this right, sorry, the amount of, hold on, I have 2 rows there and I have 2 columns there. Yeah, so you have to have the same amount of columns in the first matrix as you do rows in the second. Now, instead of trying to remember that order and that pattern, there's a much easier way to do it. And I always suggest this in all my classes, is you just write, the very first thing is when you're asked to do a matrix multiplication, you just write the size of both of them directly on top, okay, like this, and then you check these 2 inside numbers, the 2 numbers that are next to each other. If they're the same, okay, check if those 2 are the same. If same, we can do that multiplication. The result will be the size of the 2 outside numbers. So you'll know that whenever we do this matrix multiplication, it's actually going to give us an answer of a 2 by 1 matrix, which is going to look like final numbers like this, where we have 2 rows and then 1 column. So that's what I suggest. Whenever you're given any matrix multiplication, write the orders on top of it. If the 2 interior numbers next to each other are the same, it works. And if so, you know your final result will be the outside numbers. Now, if I didn't have this here, okay, we know we're going to end up with a 2 by 1 matrix as our result. That means we need to fill element 1, 1, and we need to fill element 2, 1. Okay. These elements will be made up of whatever the first number is. This will be the first matrix row, and then the second number, okay, tells us which from the second matrix column to use. And it's a little bit harder to see this pattern in a 2 by 1, but we'll go through it quickly. Okay, so for this top element, we're going to go, what color do I want? Black. We're going to look at this top element here in the next line of working out. So I'm making, in my solution, I need to fill element A1, 1. That means I'm going to use row 1 from the first matrix, and I'm going to use column 1 from the second matrix. So I'm going to use row 1, column 1, and I'm going to multiply each of the numbers in that together and then sum those. So I do 1 times the 2, which is this, and then I do that 2 times the 1, and that's going to be my top element. Then I know I need to fill the second element here, and looking at that, we can see, well, that's element 2, 1. That means I need to use the second row and the first column. So I'm going to do 5 times the 2 first, and then add that to 3 times the 1. Solve that down, and we get our final answer of 4, 7. This notation can be really hard at first, or recognizing this pattern as what's working, but you take the whole row, multiply it by the whole column, and go from there. And I think this next problem will make it a little bit easier. So I have a 2 by 2. I'm asked to multiply these 2 matrices together. Same down here. I'm going to write the order of both the matrices. Look at the inside. Those 2 numbers match. Big tick. We're going to do that. That means, and I'm going to do work over here, reading off the other 2 numbers, my outside numbers, my solution must be a 2 by 2. So it's going to look like something like this. I can call it whatever I want. I might call it matrix C. Okay, and then I have C1, 1, I have C2, 1, I have C1, 2, and then I have C2, 2. That's that notation, the idea of first number is how far dropped I've gone, second number is how far across I've gone. So knowing that, I need to fill in each of these elements. Well, how am I going to build build up those elements. I look at those subscript numbers. The subscript means the little numbers down the bottom. So I have a 1 and a 1. That means from the first matrix, I need to use the first row, and I need to use the first column. And that's what you can see here. Okay. The 1 times the -2, and then the 0 times the 0. Done. Okay. It doesn't matter which elements you do. Some people like to work down, some people like to work across. It doesn't matter. In this case, we're just going to work across. I'm going to now look at the second element. Okay. Looking at that, I can see my first number is 1, so that means again I need to use the first column. This time it has a 2 as the second number. That means I need to use the second column. And I repeat that process. The 1 times the 0, and then the 0 times the 1. I move on to my third element. I can see that it says C21. That means I need to use, in this case, I need to use the second row, and I need to multiply it by the first column, and that happens there. And then last but not least, I repeat the process a fourth time, and as you're probably starting to guess, this process, multiplying matrices is really tedious. And once we had computers and calculators that came along to do this for us, it was really handy. So this one I see, it's a C2, 2. That means I need to use the second row and this second column, which is done there. So the 0 multiplied by the 0, then the 3 multiplied by the 1. And when you're looking at individual elements and multiplying them together, you always start working left to right in the rows, and you also start top to bottom. Okay, so in this case, you wouldn't try and do, and I see some people, they go, okay, 0, and they first look at the 1. They try and do 0 times 1, and then they do the 3 times 0. That's incorrect. And then the process goes on and on. We keep simplifying our problem, and this is our final result. So, quick couple worked examples. I'm only going to do A, B, C, and I'm going to leave you D, E, and F to do in your own time. Have a go at and see what you come up with. So, 3A. So this is a scalar multiplication. 2, 4, -1, 3 is equal to, we just multiply the coefficient, or it's not really coefficient technically, it's a scalar. The scalar in front by every element inside, so we get 6, 3 times 4 is 12, 3 times -1 is -3, 3 times 3 is 9. Okay, 2B plus D. So we get 2, -5, 2, plus D, which is 1, 4. Okay, so we do our scalar, just like BIDMAS, BODMAS, whatever you want to call it, we do our scalar multiplication first. So we end up with -10, 4, plus 1, 4. That gives us -9, 8. Okay, AC, this is a little harder. I'm going to put this first matrix up here. 2, 4, -1, 3, -3, -3, 2, 7. Okay, now let's do the check. Can I do this problem? Well, this first matrix is a 2 by 2, the second matrix is a 2 by 2. Inside numbers match, happy days. Outside numbers tell us our size, so we're going to end up with a result of 2 by 2. You would think to maybe, okay, it's going to end up with a 2 by 2, draw a box that can hold, or draw matrix brackets that can hold a 2 by 2, but we're going to need a lot of space here for working out. So I'm actually going to put my second bracket over there. Rightio. So top left, that's A11, and I'll just draw it over here just to remind you we have A11, A21, A12, A22. Okay, so I'm going to do top left first. So we have 2 times -3 plus 4 times 2. That's our top left. Top right, we have, we're going to use the first row in the second column. So we have 2 by -3 plus, and we're always adding these things together, whatever our results are, 4 by 7 is our top right. Bottom left, we are going to have, it's A21, so we need to use the second row down here and the first column there. So we have -1 times by -3 plus 3 by 2. And then last but not least, we have bottom right. So it's A22, so that means we need to use the we need to use the second row and the second column. So we get -1 times by -3 plus 3 by 7. Okay, 2 by -3 is -6 plus 8. You could do this whole step in your head and get the final answers, but with signs, I like to just write it out. Avoids making simple mistakes. 2 by -3 is -6 plus 4 by 7 is 28. And -1 times -3 is -3 plus 6, -3 plus 21. We end up with 2, 3, -6 plus 28 is 22, 18. And all done. That's it. 22 minutes. I've gone a little bit over time. I wanted to be 20 minutes. I apologize. If you have any questions, you can post them in the comments below the YouTube video or also in Google Classroom. See you in class.